Okay, so now we're going to go over the periodic table. Please make sure you have the copy that I gave you. If you do not, please let me know. I'll try to get it to you. All right, so we're going to go to the anticipation guide. Please cross out number 5. We are not doing that. We're not doing that set of notes. So back on this, please look at the periodic table, describe how the periodic table is organized, compare and contrast the families. It's on page 8. So please go to that one. It's going to be after the Bohr's model foldable. All right, and again, like I said, on the anticipation guide, please cross out number 5. We're going to look at number 6. So on the left-hand side, write true or false. A table where elements are organized by increasing atomic mass is called the periodic table of elements. Write that down and please flip back to the notes. All right, so the periodic table. It's a table where elements are organized by increasing atomic number. It's called the periodic table of elements, and it's arranged by group and periods. So the atomic number, if you remember back to when we were talking about atoms and you had the protons and the neutrons were in the nucleus, well, the atomic number is just the amount of protons in the middle of the atom. And they are arranged, like it says, by groups and periods. Groups are columns, periods are rows. We're going to look more at the columns than we are at the rows or the groups. All right. And taking it a step further, the periodic table is structured into 3 different families. You've got these 3 right here. What you're going to do with your periodic table that has been given to you, you are going to color based on this. The AT is actually supposed to be yellow, so please color that one yellow instead of blue. The rest that is blue, please color that blue. The stuff that is red, please color that red. This last one right here, we're not sure if that one is actually a noble gas, or at least I'm not sure. So I just had the students color that red for right now. You could do a mixture of red and blue if you have those colors. But that one is kind of like a, okay. All right, so metals. Metals are good conductors of heat and electricity. All but mercury are solid at room temperature. And like I said, when you saw this listed as not metals, like I said, those can be colored as metals. All right, so locations of all these metals. You just saw there's a whole bunch. And like I said previously, we're going to look at the groups as opposed to the periods. Periods are flat like this. Groups are up and down. Now, the thing you need to know about the groups is they are categorized. They are put in this periodic table based on their characteristics also, along with their numbers. So all the alkali metals have the same type of characteristics due to how many electrons they have in the outer shell, making it the most reactive of all metals. So if you go all the way down at the bottom of the alkali metals, group 1, you're going to see francium. Francium is the most reactive metal. So reactive that it cannot even be exposed to any air because air has water in it. And if it touches water, it will it'll go boom. It's very, very reactive. And then if you go over one group, group 2, where it has 2 valence electrons or electrons on the outer part of the electron shell or orbits, these are not as reactive, but they're still reactive. You will find them shiny, ductile, malleable. That means if you hit it with a hammer, you can bend it. One of the metals in there that you see is calcium, and you're like, hey, whoa, don't I eat calcium or drink calcium when I have milk? Or it is, because of how it is linked with other things, is not the same as the actual metal by itself. Now, the metal by itself, when I have my chemistry kids, they get to put it into, I believe, some acid, and you get to actually see it bubble and kind of like dance around on top. It's kind of cool. The transition metals, which are all on the inside. So this inside group, this is group 1, group 2, group 3 through 13, like up to here, like all of these, even down to here, all of these are considered the transitional elements. That means that they can react differently with different elements. So it can connect with 2 or it can connect with 3. It's varied amounts of other elements that it can connect with. And then you have the inner transitional metals. Now, I know it sounds weird that I say they're inner. Oops, sorry. But that's because it starts right here. You've got the lanthanide and actinide series. All of these, they technically would be in there, but they're not. So they're called the inner transitional metals. These are all man-made metals. You're going to see uraniums down there in the actinide series. They're usually radioactive. All right, and you already saw this. We have the nonmetals. So the hydrogen that's way over there on 1. Group 1, and carbon, phosphorus, selenium, iodine, and all this group, they are nonmetals. They're typically gases for the most part, or brittle solids at room temperature. Now, when we were looking at minerals a couple units ago, I showed you the yellow sulfur. When I hit it with a hammer, when I hit it with something hard, it shattered. That means it's brittle. It's not malleable. Like if I was to hammer aluminum, which is right there, if I was to hammer aluminum, that would bend and it's malleable, like our soda cans. The location, they're on the right hand of the stair step. The stair step is usually, you'll see it like right here. It looks like this, only right there. It's right to the stair. And the one group you want to know about is group 18. It is the last one right here, right here. They have 8 electrons in their outer energy level, which means it's filled, which means they're not really reactive at all. They're very, very stable. So the big thing, please circle that they're very stable. Another thing I did mention before, the groups are put there based on characteristics. I would love for you to write that down. All right, and my last set, you have the metalloids, and antimony is also there, AT. So metalloids are elements that make up the stair step, and you'll see the stair step. They have metal and non-metal properties. They're mixed groups, 13, 14, 15, 16, 17, 8, and 17. They contain metals, nonmetals, and metalloids. All of those groups. All right. So here's the fun fact. Your body is mostly made up of oxygen. If you didn't know that. All right, let's go to quiz time. I believe this is quiz 3 or 4. I would put periodic table. 1, 2, 3, 4, 5. Pause if you need it. What are good conductors of heat and electricity? Are they metals, nonmetals, metalloids, or all elements? Good conductors of heat and electricity, they are metals. Think of like the pots and pans that you cook with. You want them to conduct heat to cook. Electricity, you'll see copper wires. They're used to conduct the electricity for like phone wires, electrical wires, all that stuff. Which family is part of the mixed group? Which one is the mixed group? That would be our metalloids. They have the metals, nonmetals, and the metalloids. It is mixed. What group is the most stable? Is it 1, 4, 8, or 18? This one is 18, the noble gases. Metals are located where to the stair step? Are they left, right, above, or below? Metals are to the left, All right, last but not least, non-metal elements are usually gases or brittle solids. At what temperature? So where are we going to find this? Is it room temperature, 100 degrees Celsius, 100 degrees Fahrenheit, or 0 degrees Celsius? It's at room temperature. Okay, please flip back to the anticipation guide. We're going to answer number 6 on the right-hand side. A table where the elements are organized by increasing atomic mass is called the periodic table of elements. This is going to be false. They are by atomic number. Number of protons. That's how you're going to remember. Number of protons. All right, summary. Sorry, my bad. The periodic table is arranged by atomic number, or the number of protons. Compare and contrast the families. So families are similar, where you have metals, nonmetals, and metalloids. So metals and metalloids have similar characteristics, but they are also different based on what you're doing to it. Same with metals versus metalloids. They do, I think I said metals, nonmetals and metalloids. Some present as gaseous, some don't. Some are good conductors of heat and electricity, some aren't. Some conduct electricity well, but they don't conduct heat very well. All right. So we are done with the notes. If you have any questions, please feel free to ask, and I hope you guys have a great day.